Hello, this is question 13 on your June 2018 paper 1 from AQA. It's a differentiation question, and you have a company is designing a logo. The logo is a circle of radius 4 inches with an inscribed rectangle. The rectangle must be as large as possible, and the company models the logo on an XY plane, like in this diagram. Yeah. Use calculus to find the maximum area of the rectangle. So we have, the only thing that we know here is that this distance here, which is the radius, is 4. Yeah? So we can write the area of the rectangle in terms of, we are going to use this dimension. So this dimension is going, we can call it x, and this dimension we can call it y. And that way the area of the rectangle, the one that we have to make maximum, is going to be this side, which is 2y, by this side, which is 2x. Yeah, so 2x times 2y, which is 4xy. If we want to make it maximum, we have to differentiate. And to differentiate, we are going to write our area in just in terms of one of the parameters. So instead of x and y, we are going to use just one of them. To eliminate one of them, we are going to use the fact that the hypotenuse of this triangle is 4. So we can write, using Pythagoras, that x squared plus y squared is 4, and that way we can eliminate y. So we know that using Pythagoras, x squared plus y squared is 4, which means that y is square root of 4 minus 4 squared, so 16 is Pythagoras is x squared plus y squared is radius squared, or hypotenuse squared. So I have 16 minus x squared. That's y, which means in my expression for the area, I can substitute the y in terms of x, and it's only the area in terms of x. So I have a is 4x times 16 minus x squared. And now if I want to find the maximum, I'm just going to differentiate that expression. So I'm going to differentiate with respect to x, and I'm going to use the chain rule, the product rule, yeah, because I have one function multiplied by another function. When I use the product rule, I'm going to differentiate this one and multiply by this one without differentiating it. So 4 times root 16 minus x squared, and then plus, I'm going to leave this one like it is and differentiate this one. So plus 4x. And to differentiate this one, I have a square root of a function, so I'm going to use the chain rule. And I think I'm going to do just on the side, yeah? So if I want to differentiate 16 minus x squared, when I differentiate, I have using the chain rule is let me write in a better way. So this is going to be 16 minus x squared to the power of 1/2. So when I differentiate this one, I differentiate something to the power of 1/2. So it's going to be 1/2 at the front, my function, to 1 power less, so minus 1/2. And then I'm going to multiply by the derivative of my function, which is 2x, minus 2x. Yeah, I can, simplify a bit, but not too much. So I can have x minus x in the numerator and root of 16 minus x squared in the denominator. Yeah. So that's my derivative of this function, which is this function here, and that's what I'm going to multiply here. So I leave this one and multiply by the derivative of that one. So I have to multiply by minus x square root of 16 minus x squared. That's the derivative of the area. To find the maximum, I have to make this derivative equal to 0, and that's what I'm going to do. So I'm going to make, to find the maximum, this equal to 0. And that means this is going to be 0, So I have 4 root 16 minus x squared minus 4x squared divided by the square root equal to 0. I'm going to multiply everything by the square root. And then when I multiply everything, this square root with this square root are cancelled. So I just have the function, and I have 4 times 16 minus x squared. So 4 times 16 minus x squared minus 4x squared. Yeah, because the root is cancelled when I multiply. Minus 4x squared equal to 0. I can cancel the 4's. Yeah, I can divide everything by 4. So I have 16 minus 2x squared equal to 0. So 1x squared from here and 1 from here, which means x squared is 16 divided by 2, which is 8. So x is going to be root of 8 or 2 root 2, if you prefer. Yeah, that's x. That's the x that is going to give me the maximum area. So just to find the area, I'm just going to substitute my x in the formula for the area, which is this one in terms of x. I could find y and substitute here, but it's just easier to substitute here. So area is 4x, so 4 times x times root of 16 minus x squared. Yeah, just substituting x in the formula for the area. And then we have, so this is, this all is 8. 16 minus 8 is 8. So this is root 8. So I have 4 times 2, 8. Root 2, root 8. Which is root of 16 altogether, which is 4. 4 times 8. You can do with a calculator if you prefer. 32 square inches. Yeah, that's the area. And that's the maximum area. But it says fully justify your answer, so we still should check that this is maximum area, because it could be a minimum. We just know that the derivative is 0, which means it could be a minimum. So let's go to check that it's a maximum. For that, we could find the sign of the second derivative. So we could find second derivative, and if it's smaller than 0, it will be maximum. But if you see your expression for area, for the derivative is all this, derivating again this function is quite long, and it's a bit complicated, mainly again here, because you have the quotient rule and then the chain rule, so it's quite long. I would recommend you in these situations just to check. So remember, when you have a maximum, the gradient of the tangent before the maximum is positive, then is 0 in the maximum, and then is negative after. Yeah? So what we can do is to check. We know the maximum is in 2 root 2. Check a point to the left and a point to the right and see that they are greater than 0 and smaller than 0. Yeah, that would be much faster way. So our x is 2 root 2. So x is 2 root 2, which is 2.828, something like this. So we can try a point to the left. So for example, 2.8, and a point to the right of that, x 2.9. And we are going to check the derivative. We are going to see the tangent. Yeah, so the derivative is giving me the gradient of the tangent. So when I substitute, and this is much easier because I'm going to substitute 2.8 in my derivative, which is this one. It's long, but you just put 2.8 with the calculator, yeah? And it's just using the calculator for that. If you do that, you get 0.448, something, yeah? And we are going to do the same with 2.9. So the gradient of the line when x is 2.9 is, substituting again, minus 1.911, which means before my point is positive, then at my point is 0, and then after the point is negative. So that means I have the maximum. Yeah, so that's enough to prove that is a maximum. So therefore it's a maximum. is the maximum. Yeah, and that's all what you have to do. That's all with this question.